Physics 40S, we have our second video using the motor generator model. So you'll notice I made a change. Nothing changed with the external magnetic field. We still have the armature, but I removed the two slip rings. And you'll notice when I rotate that this band of plastic here is in two parts. So this part is now called a commutator. It's called a split ring commutator. So we would have been a continuous ring, but it's cut in half so that we have two locations where it's open. Now the brushes are still the same. They're still in place so that as the armature rotates, we would see the contact with the brushes and the commutator changes. Okay, so how is this different? It's still a generator if I rotate using wind or water or something like that. I rotate this armature in the external magnetic field. So mechanical energy goes in, electrical energy is going to come out. So I'm going to use my velocity vector arrows into the page. Hey, this feels a little bit like deja vu, hopefully. So we have current coming, or not current, sorry, velocity into the page, fingers going that way, palm faces down, which is technically EMF, but we're going to just say current for now just to keep things moving. Here, same idea, velocity is coming out of the page, fingers go from north to south, coming up that way. Okay, so that's exactly what we did before, but now when we follow that current, comes around the armature, goes into the commutator, out through the brush, and around the external circuit, I could say kind of this way, coming around, in, and there. I don't know if you guys can see that current vector that's kind of coming out here. I'm representing it coming out this way, and then we could say current is coming in that way. Okay, so current comes out, goes around, lights a light bulb or powers something, but does something over here. So that's during our rotation. So we're generating a voltage at this point. Okay, great. With pi, you're kind of repeating yourself. Everything seems like it's exactly the same as before. But what happens when I rotate here? Okay, velocity parallel, current disappears. You'll notice the gap on the commutator is the thing that's at the brushes right now. So we're generating zero EMF and therefore zero current at the same time as those commutators are bridging the gap, right? So we have them going across the brushes, touching the gap right now. So we're down and we have a voltage of zero. So then I continue my rotation. Now you'll notice if I was at an angle, the sign of this angle would represent the amount or the quantity of the EMF, but we're really only interested in, like, to quickly explain things at the zero and the maximum value. So here I am again moving at 90 degrees. So velocity, magnetic field, palm facing down, we're getting current in here. And then we're going to have over here coming out of the page, magnetic field, current coming this way. Now let's trace it. Comes down, goes through, into the commutator, into the brush, and out through the external field. Notice direction exactly the same. Wait a second, that's what's different. So now this side of the commutator, which was on that side before, is now touching this brush. And this brush is receiving this direction of current.
Message at the front door for Ms. Shaw. Ms. Shaw to the front door.
Announcement in between, that's okay. So you'll notice that now the voltage would be in the same direction as before. So what has happened is our thing that used to look like this has now gone back up and down. Really cannot draw. And then it would keep going over and over again. So we've eliminated the negative. We've rectified the direction of the current, and we've created a DC generator. Okay, now, how do I make that a DC motor? It's exactly the same structure, But now, instead of rotation, now I put current in. So now a DC motor has an armature, split ring commutator, brushes, and external field. But now I add current. I put a battery in to generate some kind of current. Current comes in, and then this current has its own magnetic field. The magnetic field of this current interferes with this magnetic field, and we end up with a force. I don't have a force vector arrow, but if I have current coming in this way, current, magnetic field, now you'll notice the force is going to push on the armature, so it's going to push it that way. Well, let's see what's going on here. Wait a second. I can't have current going those two directions. It has to go in. It has to be in one continuous path. So the current comes down here. Fingers go from north to south. Force is going this way. So on the right-hand side of the armature, it was going into the page. On this left-hand side, it's coming out of the page. Well, if I push in those two locations, what do I get? I get rotation. So electrical energy went in and mechanical energy came out. We'll talk a little bit more about the theory in another video. Thank you.